this episode number 5, learning Amiga assembly with Docster. Hello Docster also. Hello Gary. Hello Hound Dog. So let's go to the usual thing. Let's go to the what I normally say. So please yes, but I didn't trash, I just left them behind. So as always, please like and subscribe to my YouTube channel. It's the only way I know of how to share stuff. Remember that under each video you get links for more things, source code. I think I edit also more commands, Hound Dog. You can check them out. Yeah, I edit more commands. But they are still... There is more actually, but you cannot still see them. As also, please like and subscribe. Join the Phase 101. Sorry. Like and follow. Like and follow, not like and subscribe. Like and follow the Phase 101 page and on Facebook, and the Phase 101 Facebook group. Okay, this is join now. So join the Phase 101 Facebook group. By the way, for those that never asked or do not know why I have this logo on the Phase 101 group instead of my usual logo, it's because this one was made by the excellent 3D graphic designer Hound Dog, and I liked it, and yeah, I left it there. Basically, I do like it a lot. Also, please join the Commodore Dev Facebook group, and if you want to get in touch with me, the right place to get in touch with me is Discord. You can write to me on Facebook. I do reply on Facebook to anyone, but I take longer. On Discord, I'm faster, let's say that. For those that do not like Discord or Facebook, I also have a Telegram, so you can join Telegram. And if you want to go that extra mile and support us, then there is Patreon, and I'm noticing now there is 101 videos to unlock. Funny enough, I didn't plan this. I really didn't plan this. There is 101 videos to unlock, and same on Coffee. So they are identical. So whichever you like, just join whichever you like. Also, please note that I have this page where I share links related to 68,000 development, which I think Hound Dog has already shared, if not mistaken. I want to make a small link to this one, which I always forgot. Actually, let me write it down. Because it's a long one and I want to make a smaller one. Okay, so from there we jump to our lovely Amiga. As you can see, my Amiga is switched on, okay, and I do have the assembler on my screen, but unfortunately I have to use the emulator. I had the intention of doing this from the Amiga, but um, it's one of those things, as I said. Now, before I start, I need to say a few things. I'm going to start covering the commands, okay? The not the commands, the instruction set of the 68,000. Some of this stuff was given to me by uh, yeah, okay. Some of this stuff was given to me by Docster, okay? So this is why this stream is named after Docster, because he did give me quite a bit of things to go through. There are other things that I edit myself, and there are things that Docster did and I split them. Yeah. It's coming, okay? Loyalty points. It's coming. Add points to all viewers. And you got your points. Docster is the top. Anyway, and it's very hard to reach him. From what I see, yeah, it's very hard to reach him. He even bypassed myself. Docster, do you have a video? I wanted to ask you today if you put a video of the game. If you have, I will share it. I will show it. So, let me make this small now. Okay. Anyway, up to you. If you have a video, I'm happy to share. So, today, as I said, I'm going to do the instruction set of the 68,000, and I'm not going to cover it all, okay? I'm only trying to cover those that are you know, for beginners, okay? It's not, you don't need to know the full 68,000 instruction set. And even I myself don't know it. I mean, sometimes I have to look it up. So yeah. Let me find something that I need. Because else I will make a mess. Okay. And I need this. Yeah, that's fine. And what else I need? Okay, this one. Let's start it up. Okay, so let's go to the dev screen. Okay, so let's make it a bit bigger. So remember the sheet that I had shown? I mean, they were in the slides, okay, these. And which instructions were for beginners, or you should know as beginners, and those that you can ignore, or you can go through them later on when you get more. Yes, exactly, Doctor. I agree with you. It's not because if you can, everybody can. Everybody started from zero. Okay, so the instructions, okay, as I told you, for example, like move A and move M, you can write them as move, but I prefer, for example, move M to write not move M, move quick. I prefer to write it as move quick to be indicative that it is move P, move peripheral data. That is not, sorry, this should be like that. I just noted a mistake. So we'll cover most of this today, not all. I don't. I don't think it will. We need, because if I do a lot, you get also not bored, but you will start to be, let's say, uh, losing concentration. So yeah. Docster. I was referring to move quick. Move quick. You don't. I prefer it. I prefer to write it. So, I will cover the move instruction. Okay, the group of move instructions. I will cover LEA. There will be some instructions from further down which we'll cover again, but for the examples we will go through them. And probably this is where I will stop. I do not want to go through into too much detail when you are learning the instruction set. I think people get bored or distracted, let's put it this way. But the best way to learn is by trying the examples, of course. So I need to jump to the Amiga first. So this is the first example, okay? Let me minimize because it's blocking my thing. So we just have 3 instructions, okay? All of them are the move instruction, and remember, you can specify byte, word, and long word in terms of size, okay? And in each one of these, we are moving a value into a data register. In this case, it's the 0, it's the 1, and it's the 3. This info was given to me by Docster, but I trust him, let's say that. And it does set the negative flag and the 0 flag. The V flag is always cleared and the C flag is always cleared when you do a move. Also remember that the 68,000, you have source and destination, okay? After the comma is the destination. Just a bit of revision of what we did, basically. So, I am in Pro, okay? So, back to the roots. And I wanted to do this on the Amiga. To assemble and debug on Pro, you type AD, okay? Now, before I do it, okay, it's good to do A alone, okay? Why? Because if you do AD, it will assemble and start debugging, but errors that you might have in the code, in the assembly code, I mean, okay, like, I don't know, you forgot a comma or a label not referred, they will be skipped. It will still go into the debug mode. It will not stop because it's 2 commands in one, basically. So it's good to make sure that it assembles without any errors, okay? And then you do AD, okay? And you get this screen. You can see that the registers are all cleared except the stack one, okay? And of course the supervisor and user, I mean these two, A7, okay, and the user stack pointer, the USB, okay, they are the same. In this case, the supervisor mode stack pointer is also is different. You don't be fooled. Look, there's an D, not an E, okay? So that is different, but we are not in supervisor mode, we are in user mode, okay? The SR shows us the status flag, and here we have the program counter where it is, the VBR where it is, etc, etc. But what we are interested most is these registers from D0 to A6, okay? That's what we will be working with. So, to execute an instruction, okay, in the assembler, I mean one step at a time, okay, you just press the down arrow, okay, and you will see that we are going to move a byte from which is FF. We're going to move a value, sorry, not a byte, which is size byte, of course, to the 0, okay, and you can see that in the 0 we have FF, okay. So I'm using this there is another example, okay, which is very similar to this one, but I'm using this example to explain also the assembler in a way, or the debugger in a way, of the Amiga. We will do the same thing on the A68K simulator, and yeah, I'm not going to go this, I'm not going to do this in Visual Code. Visual Code, the disassembler of Visual Code is not good, let's say that, for such simple things, okay? So I'm not going to go into that. Maybe for disassembly using Visual Code, I have other videos where I explained how to use it. And actually, that's another note. I need to group them so that somebody can go and play the playlist, basically, of them. Visual Code. Okay, so now we're going to move a word. So again, arrow down, and you will see that D1 will have a word in it. Remember, the registers were cleared when we started this this session with the debugger, let's say that. But when you move a word, the upper bytes, okay, do not get affected. Well, even if when you move a byte, okay, so even when we did this, so if there was something in the register, it will not be cleared. And the same thing, we have the last one where we move a long word, so 4 bytes, into the 2, okay? And is there to show end of assembly, end of, trying to assemble. It's not end of program, okay? I just did it there just also to maybe not confuse people. So that was our first example, and I'm going to pass to the, where is it? I'm going to pass to using the EZ68K assembler, okay? I do like it for testing quickly the instructions, I have to say. It's very handy, it's in Windows, it runs in Windows, and I like it. For Linux, there's another one that runs in Java, okay? The disassembler doesn't work on Windows of it, so this is why I'm not uh, using it. But I did share the links. I can share the links again. Um, this is the link for the Easy68K, which I will paste. And 68 simulator, I have this link. I'm not, I do not have, let's say, experience with this much. This one I hardly used. I tried it and I found it, you know, not as good as the 68K, Easy 68K. Also, as I said, on Windows it has issues. I think the assembler, not I think, the assembler for some reason didn't want to work. But I'm pretty sure it's fine on Linux. I didn't try it, but yeah, that's how it is. So, this one, the Easy68K, okay, to use it, okay, I have the code. Basically, it's a simulator, okay, so we are just going to test instructions. I just copied the 3 instructions that we had, okay. This one needs to be there, okay. So when you open the program, it tells you insert the code here and do not touch anything else, basically. So I just left it as it is and inserted the code before the sim hold, okay, hold the simulator. To run the code, you do here this one, assemble source. It gives you this window that all is fine. Sorry if it's small, but it doesn't have, it has to, you can make this bigger, but you cannot make such windows bigger. Anyway, execute, and it gives you this window. And again, you can see this one shows us the instructions and also the code, the opcode, the values of each instruction that we have. Notice, and this is why the 68,000 can only work with even addresses, okay? Notice what it did for move byte. Hold on. Do you see the screen the way it should see? You should see it. Sorry. Sorry guys, I didn't realize. So, as I said, we have the 3 instructions and their opcode values. And as I also said, the 68,000 only works at even addresses, and you can see it here also. They are all even addresses. But for move byte, okay, you think, oh, I'm saving 1 byte. No. It inserted 00 in front of it. It always works at 16. Okay, so it's one of those things of the 68,000. In fact, when I learned this, I practically said, okay, might as well use everything .word and no need to use .byte. But yes, it's one of those things. Because it's still using the same amount of memory and it's still using the same instructions. Oh, hello, School Coder. How are you? We just started, to be fair. Just a little bit we've done. So yeah. And to execute the instruction one at a time with Easy68K, you just click on this arrow up here. Now, unfortunately, this part where the registers are, I cannot make it bigger. I can make the text bigger, but not this part. So it's one of those things. Oh, school coder, stop thinking of 6502. Hello, Dr. Honey. So, with Easy68K, no, I review. This should have been. Thanks for the ISO. And can you please also do for old school coder, Hound Dog? SO, not SP. So to execute the instructions, okay, you click on this arrow here next to the pause, okay, and you can see that we moved FF into the 0, okay, and we continue doing this with it word now, and you can see that we moved the value into the 0. Again, we moved 4 bytes into the 2, and that's how you basically use the Easy68K to check instructions. By the way, this simulator is quite, it has its own screen, it has its own tools to program LEDs, etc. So you can do quite a lot with this. If you go and check the website, you'll see you can do a lot of things with this simulator. I'm just using it to check the instructions and what they do. Okay? One thing that I didn't, let's start again from the beginning. Okay? One thing that I didn't check is the flags. Okay? Here we can see them. Again, why it's... This should be also here. Sorry, I forgot, because you can also view memory. I forgot to drag it. So if I had to, let me, I believe if I click, I forgot how I did it. To go to the memory location here. Come on, old school coder, forget the panels. Now it's 68,000 time. Yeah, and you know, the move instruction is the same as there is in 8086. Well, the same. They need to do the opposite, but yeah. I always make fun of the 8086 for reasons beyond me, because they come from when I was a kid, you know. Anyway, I still like the 8086, don't get me wrong, but I always consider the 68,000 much more better. Call it copy. So, as I was saying about the instructions, I just want to show you the flags. Okay, as you can see, the negative flag was set because we moved FF, so the high bit was set. Because I'm using FFF all the time, the negative flag will always be set. Okay, let's go to the Amiga and do example number 2. So this example is also coming from Docster, I think, or part of it. Let's put it this way. So let's run it. So remember, do A to make sure that there are no errors, and then do AD. So now we are moving into D0, D1, D2, D3. 4 long words. Okay, so you're going to see them all FFF. Okay. So D1, D2, D3. Now we're going to move a byte. So this is similar to what we did before. Okay, but notice that we moved a byte of 10. Okay, but look what happened. The high word did not change. The low word did. Even though we said it's a byte. Because the 68,000 always reads 16. Now we're going to move 10 again into D1. Sorry, I need to, I made a mistake. We had move without the specified size. Okay, it always defaults to word, so that's why the 0, okay, is 000A. Okay, and the others were not changed. My god, that was a very big mistake that I made. Now we're going to move a byte. And you see that it moved a byte into D1, and the rest remained as they were, FFFF. Okay, and honestly, the mistake that I did before is very bad, because I was thinking to myself, how can it be that it moved, put also zeros. But anyway. So now we're going to do D2, and it's a word. So now D2 should be the same as D0, because the default is word. And you can see the same thing in D2. And last one, we have move quick. And notice move quick, how it is written. Okay, move Q. Okay, move quick. And move quick is always a byte, which with a value of -1 to 8 to +1 to 7. And it affects the whole long word of the register. Okay, so if we had to move I don't know, -1, okay, the high bit will carry on through all the others. Yes, agree. Now, this is losing me every time. We did move long and now we did move quick. Every time I'm thinking that I am doing the instruction which is highlighted. Um, what we did is move quick 10 into the 3. So notice that 10 into the 3, okay, is the same as the previous one, move long 10, the 3. As I said, it affects the whole 4 bytes. Now we're going to move the 0 into the 3. This is a normal register copy, so whatever we have in the 0 goes into the 3. And your comments, Doctor, I didn't realize. I should have corrected that. It should be the same. Anyway, I'm going to correct it actually. So that was example number 2, but I'm going to do this one also in the simulator. I'm not going to do them all in the simulator, okay? Just to be clear. But to see a little bit more of the simulator. Oh yeah, definitely. Well, to be honest, if you write move quick, yes. If you write move and you intended a move quick, it will convert it, no? So, yeah. So, let's jump to the um, screen. Here is the code again, okay, in the simulator, and let's run it. And as always, it opens screens on a different screen, so I have to go and grab it and go and grab this one. Hound Dog, I didn't, maybe I missed some messages of yours. No, there was, because the zero had FF 00 OA, and in the comments there was 00000 OA basically. So no, we're going to see it anyway now. So same thing. Let's execute them one by one. So we're going to have 4 registers with 4 long words of Fs. Okay, so you can see them here. And now we're going to execute 10, did 0. So look what happens. We have FF0000A. So for the question that you asked, Houndoc, no, I corrected the comments. There was a mistake. You will see that the value that we have here, we will copy it into D3 eventually. Okay. So we're going to do move byte immediate 10 into the 1. Okay, so we actually did that. No, sorry, we again, I was lost. This is move.word, okay, because there is no not specified. You can see that we have the 00 added there, and that it moved a word. Then we're going to move a byte. Okay, so D1 is going to have a byte, so only OA is affected. Next one, D3. Okay, we moved 10, but it's sorry, D2 we moved 10, but it's a word, so D2 is same as D0. And now we're going to do move quick 10, D3. So D3, okay, you're going to see that it affects the whole word. The long word, sorry. Okay, so all the rest, the high bit was copied through all the other bits in the long word. So if it was a minus, it would have been copied also across. So you need to be careful when using move quick about this. Then next instruction is move long, okay, what we have in D0 to D3. So we have this, and we are moving it into D3. So it will overwrite everything and have the 4 Fs 000A. Okay, think that makes sense. Yes, if you don't specify, it's always a word. Read again the comments. What I'm missing in the comments? You can tell me. Let's go to the Amiga. Let's put it this way to make things simpler. Tell me the line where you are want me to read. I see what you mean. Should be. Okay, I read it wrongly. Yes, okay. Sorry, Docster, you didn't have an error. because there was should be. Okay. Update again. It's just the wording. Okay, so my god, for only 2 examples we did. Come on. Third example. We have a label down here and we have hello world, okay? And we're also taking the length of how long this string is, okay, that we have here, okay? And you do this in 68,000 assembly, like in 6502, by using the EQU or equals, if you want, the star minus hello world, okay, this label basically. So this should be familiar to those that are 6502 people. Those that are 8086, it's a bit different, but yeah, that's the way it's done. So what we have here with these 2 instructions, there is only the hash different between one and the other one, okay? What really happens, okay? And we are going to see what really happens. So the first one, we are going to move the address of the label hello world into 80. Sorry, we got eagle eyes. We're watching you, mate. What have I done? Ah, because of the correction. Oh god. Good one. So notice the debugger. No, guys, this is important for when you are writing assembly code and using the Asm Pro. Notice the debugger remembers what values of registers you had before. Okay, you see them still there, populated as they were before. Okay, we loaded a different program, they did not reset. Okay, so they are not cleared. Only the first time that you run it, they are cleared. I don't know if it's a bug or a feature, this one, but I would say it's a feature. Anyway. So let's execute the first one. And you can see that 80 has got the address of the label, and we can verify it later on. Okay? The second one has moved. Actually, let's do something. Okay, I'm going to modify the program a bit, just for the sake of maybe making it more clearer. And actually, no, leave it like that. Let's execute that, and we should have the address. So that's the address where the label is. And now when we execute the next one, notice that A1 doesn't hold the address of the label, but the contents. So the 48 is an H, the 65 is the E, the 6C and 6C are the double L. So basically, you're actually telling, get me the contents at this address, okay? Without the hash. It's a really common mistake, forgetting the hash. So Docster just wanted to show what happens when you do this. And actually, I prefer the example as I did it, so I'm just going to okay, is that clear? Notice also that after the two moves, I have an RTS, okay? This is to return back to the assembler in a way. Change, what line? '22. Yes. Oh. Because Doctor actually had howdy when he did the examples. Yes, so thank you, Doctor, for that. So to show to get the memory where the string is, you just type M hello world. And you start seeing the contents, okay? Now there is a 0, okay? So when we see the 0, we know that we have the whole word, okay? Now, if I continue pressing return, it means it should be everything 0 now, okay? Or whatever the memory is behind. But it's random values, okay? It's only till the first 0 that we have our string there. Ah, yes, it's hell. Thank you. I like it. It is hell in a way. Anyway, so the M command and the label will tell you that, okay? It will tell you where the string is and I think I missed the letter. Where? P. For what? P for what? Ah, no, it's hello. It's the four. It's 4 bytes. No, it's hell. Anyway, so that was the third example. The fourth example. This one shows indexed addressing, okay? It's not really, there's no loops, but to show what really happens. So, again, we get the address of 80, of hello world into 80. Then we move the first byte, okay, which is the H, capital H, into the 0. And notice we got the 48. Then we move again, okay, the first byte, okay, byte 0, so that there's a, what Docster wants to say here is that there's a 0 hidden in front of this one, okay? You can write it like this, or you can write it like this. It's still the same thing. And you will see that D1 will have the same number again. In the first byte, we have 48, okay? Because we moved a byte. Now, we're going to move the fourth byte. Remember, we start from 0, okay? Into D2. And there you go. You have the 6F, which is the 0. The O, sorry, not 0. Okay? So, this example just shows how you can specify index to an address. Yes, basically yes. But in 6502 you always have to specify an X or Y, no? In 0 page, right? Yeah. Yes, exactly. It's similar like specifying an X or Y value. Exactly. So, still wrong though it's copy. Example 5. Now, this one I modified it a bit and changed quite some things from it, from this example. So, you're going to see for the first time the LEA instruction. So, we have move.long, okay, hello world, comma 80, okay? So, once we execute it, 80 should have the address of hello world. Okay, and we have 40183FF44. LEA, in this case, does the same. You can see that 80 still have the same value. Okay? Why LEA and not move.long? When referring to addresses, okay, load effective address is better, let's say that, than move.long, immediate and a label. Also, with LEA, you can use relative. So, I'm going to exit again and go to here. I could have done this. Now, this will shorten the instruction and make it a lot faster. So, it's one of the reasons why LEA is preferred. Because you're telling where is the label, where the label is, okay, and give me the address relative to where this instruction is. I'm just going to put it back as it was because LEA will come later on. Just in case it needs an update. You're going to start seeing that I switch from move.long, immediate and the label, to LEA. Anyway, in 80 we have the address of the hello world. It only works if data is in the same section. We haven't covered that, and we are not going to go there. It works always in the same section. Remember, the Amiga uses chunks. Okay? So you have the code section, the data section, the graphics section, the sound section, whatever. They are all sections. So you can have as many as you want. And the section is normally similar, but you do not need to use them like 8086. 8086, you need to use them. You are forced to use them. In Amiga, no. But it's a way, in 68000, it's a way of organizing things. While in 8086 you are forced, because even the registers are made like that. And each section is also like 8086, 64K. You can have it longer, but the relative path, so as I did before, having PC in front of LEA, in front after the hello world, it will only work within the minus 32768 and plus 32767. Okay, so a chunk, a section of 64K. In other processors further up, this was even not anymore an issue. But anyway, but in the 16-bit world of the 68000, that's how it was. But you don't really need to. In fact, most people never use sections in 68000, especially code that was written in the beginning when the Amiga, when everybody got an A500 and had 512K of memory. Nobody bothered of using sections. I learned to use sections when I bought the expansion to the A500, because I said, okay, why when I unplug the memory the code works, and when I put it in it doesn't work? And I learned that I need to specify a section if the code needs to run in chip mem or fast mem. So you specify a section and you tell it, okay, my code needs to be in chip mem. Yeah. So to be honest, it's not the code, it's the the graphic sound, etc. of the Amiga. But yeah, That's how most of us learned about the section directive. So yeah, if you buy an A500 standard A500 512K, with no memory expansion, you will not use the section directive till you buy the expansion card and you start experimenting and seeing the code, swearing at the code. Anyway, so A0 points to the hello world. Now we're going to copy from A0 into D1, but we have also an increment, that plus after the bracket. That means copy from A0 the byte that we have at A0, okay? Copy it into D1, but also increment the address in A0 by one because it's a byte. No, it's not a bad thing. It's just, nobody thought of. Remember, I had the Amiga when there was no expansion for it. Okay? It's the one behind me, okay? It's somewhere down there. You see the monitor and you see the Amigas behind me. It's still there. It's that one, okay? That did not have. It was Kickstart 1.2, came with 512K of RAM, and that's it. And Commodore released the 512K expansion for it. Not immediately, there was, I would say, nearly a year or so when they released it. So, and it was quite expensive. It was 100 Maltese lira, which is, if I had to say it in euros, it was like 250, okay, euros. So, yeah, it was not cheap neither when it came out for 512K expansion. But yeah, that's the thing. Anyway, so you're going to see that 80, when I execute this instruction, D1 will have the value in 80 and that 80 will increase. Notice it is F4. It ends with F4 right now. Once we execute it, you see it went into F5. And D1 has got 48 in it. Yes, but the A500 was released in 1991, I believe. A500 Plus. I had the Amiga in 1987 when it was released. In fact, I had to make a modification to it, to the one that you see, so that, because then I bought the GVP A530, and to work the GVP A530, I had to change the kickstart, because I had kickstart 1.2, and at minimum it needed kickstart 1.3, because kickstart 1.2 does not recognize hard drives. So, yeah. So, from this instruction, we do another one, and you're going to see that 80 from F5 will go into F6, and D1 will have the next byte available. So 48 will change to 65. Lucky you, Docster. Basically, you had them all like that, nearly. So, now, notice we have the same as before, but we have a minus. decrement means decrement. Now the decrement happens before, that's why it is also before the bracket, happens before we copy. Okay, so first we decrement and then we copy into D1. You worked as a fisher, so what? You were fishing them in the sea? I would have been a fisherman if I knew I could get them from the sea. So notice what's going to happen to 80. It's going to go to F5 and then copy it into D1. Okay, you see that it's 65 now. And now we're going to do the same thing. It should be 48 if I remember correctly, the first one. So it's going to become F4 and copy the value at F4, well, the address ending F4 into D1. There you go, it's 48. Hello, Fewbit. Ciao. Hound Dog, can you do an SO of Fewbit, please? Guys, Fewbit does retro games also. He plays retro games of Commodore, I believe also Amiga. So if you want to follow him, please do. Normally he streams very late at night when I'm going to sleep, and it's one of those things that I most of the time when he's on I look at, and you know, I just watch his stream. Yeah. Ah, Docster, you're in competition also now. My moderators are in competition. Anyway. Ah, I see. Anyway, now we have further down. It doesn't let me scroll, so I'm just going to, if I exit, then I will have to start again. So besides hello world, I will show you later on in a minute. Actually, no, I do not need to do that. I'll show you what I'll do. I'll tell you what I'll do. Let me open it in. Let me open it in Notepad. So, and I need to change screen, I assume. Left screen. Yeah. I guess you can see it like that, no? So, at the bottom, we have what we had before, hello world, but we also have a buffer of 20 bytes, all initialized with 0. The DCB means define constant byte, okay? Define constant block, sorry. You can also use BLK, but in fact Docster used BLK, but BLK was superseded by DCB, okay? Define constant block. In fact, not all assemblers support BLK. It's better if you use DCB, especially if you use the extension, unless you tell the extension to support as in 1. So again, 20 bytes initialized to 0. Okay, one other thing, notice the even directive. Okay, Docster did not put this, but I always insist, especially when you have a string, to have the even directive afterwards, because all labels needs to start at an even address. If you forget the even, and this label, this string, okay, is odd, not even in length, okay, then you'll get a guru. So always include even. I removed the 0 intentionally because now the word is 11 bytes. Hello world. Okay, the string. No. You had comma 0 there. So in theory, you did not need the even directive because you were even. Okay, but it's always safe to put the even directive. I changed it without the 0, or you had 13. I can't remember. I know you had the value after hello world, and I changed it so that I show the even directive. So back to the Amiga. So we're going to copy from hello world to buffer. Okay, so we're going to copy the string, and I will show it to you with the M command again. And notice I'm using LEA, not move immediate. Okay, there's a typo here. Holds. Yeah, I can correct it here actually. So notice that 80 is going to have the address of the hello world, okay? And A1 is going to have the address of the buffer. You can see that they are quite close to each other also, because they follow each other. Now in the assembly code we had hello world, then the even directive, and then under it we had the label for the buffer. So we're going to copy, okay, the first 3 bytes, right, till here, because then another section will start. And notice the increment. Notice that source has an increment for the address, so we're using post-increment, and even the destination this time has an increment, does an increment. So notice that when we execute the instruction, F4 will become F5, and the 00 will become 01. Okay, so there you go, and we copied what was in A0 into A1. Okay, we do it again. It increments F6 and O2. Okay, and last one F7 and O3. So we copied 3 bytes into the buffer, okay, from one place to another. Now, of course, this is to show post-increment. That's why it's there. Now, we're going to jump a bit, okay? We have the same example, but with a loop, okay? So, again, below the address of hello world using LEA into 80, and the same thing, buffer into A1, okay? So you can see them, one ends with F4, the other one with 00. So we are back to where we were. Now we take, and notice Docster is using move quick. I left it there I wouldn't have used moved quick, but I left it there to explain why I wouldn't have used move quick. The string, as long as it is less than 1 to 7 bytes, it's fine. But if it was longer, that's a bug. So in this case, it's okay. But I would not use move quick for such a thing. It's not. It's sometimes it's good to use move quick. Sometimes it's not. When you don't know, it's better not to use move quick. Strings can be of different length, so you can have you will want to use the same routine for different things. Let's say you have different strings, and that will not work because you will have strings like a scroll text that will not work if you had a scroll text. Okay, because you will exceed 1 to 8 characters. But yeah, in this case it's fine. So I'm not saying to avoid always move quick, but with strings it's better to be careful what you use, because you are limiting yourself to 1 to 7 characters. On the 1 to 8 character, move quick will go negative, and that means the number will be very, very long for to copy, let's say that. So notice the 0 is going to have the length of our string, which is 12. Is it 12? Sorry, 11. Yeah, that's the length of it. So now we have the same instruction as we had before, A0 into A1 with increment. So we are going to copy. However, now we have an instruction, decrement and branch. Now, I am old school. Yes, I am old school. Okay? I prefer decrement and branch. D and BRA. Okay? Decrement and branch. Docster use decrement if not false. Okay? So DBF. It's the same thing. Okay? It's the modern way of using DBF. I went for the old style. Okay? It doesn't matter. Most of the time in source code you find DBRA, not DBF. DBF came with the 68020 when the Motorola changed to a higher processor. Yes, I know. I'm still using the DBRA. It doesn't matter. But in this case, it means the same. Okay? It doesn't change. Decrement till it's not false. Decrement till it's false, sorry. So it's true when it's 0, no? So basically what will happen here is the 0 will be decremented. We have the 0, we have the B in it, so number 11. So we're going to decrement and loop. Now I left this also, and I did this intentionally, okay? There's a bug there. Do anyone can guess what the bug is? I didn't put it in the comments. So Our string is 11 characters, but we start from 0. So the move quick should have -1. So hash hello world len -1, comma the 0. Is it clear? Do you understand what I mean? So I'm going to execute it, and you will see that we will actually copy 12 bytes, not 11 bytes. So I'm going to continue. It's going to execute. You will see that we'll also execute 0. So 3, 2, 1, and 0. So we copied 12, not 11. Exactly. This bug is common. You forget to do the -1 when you use DBRA or decrement and branch DBF, basically. That's it for this example. Yeah. So now we need to read from a table. I modified this Docster, as you can see. Now we are not looping to read from a table, but we are just wanting to read one item from a list. Okay, so we have a list and we want to read from it. So as you noticed, I removed the move.long hash tables that Docster had and put LEA. Okay, so we have the address. They call him Docster the Modified. So in 80 we have the address of tables. Actually, I'm going to go back to the previous example. I forgot to show you something. I should have showed you the copy of memory. So let's execute it quickly. Okay, it did it. So hello world, and we have our string. Okay, until we have 0. That's our string. Okay, I could, if I continue, I will start seeing the buffer. Okay, there you go, 48, 65, it's matching now. And we continue, 57, 6F, 72, 6C, 64, 0, and guess what happens next? We have another 0, because where the 48 was, there was 0, no? I assume. Right? Am I saying it right? Yes. The string is still 64, sorry, because we did not in my example, sorry. In my example, hello world doesn't have comma 0, okay? So when we copy, okay, because there's the even directive that inserted uh, at 0, okay, to be even. So here, okay, this label, the buffer, starts at this address where I have 48. So this 0, okay, is inserted by the even instruction to be aligned at even addresses, okay? But when we copied, okay, we also copied that 0. Luckily, I believe, okay, I might be wrong here, let me continue. The memory was blank. Well, not really, but yeah. So it didn't damage anything and it didn't cause any issue, the fact that we were copying 12 instead of 11, okay? But we should only have copied uh, 12, sorry, 11. So to show you actually better, let's do one thing. Let's change it. Let's put FF. Okay? And let's run it again. And you will see that the FF is copied. You see, so we have FF, so we ended our string. You will see that the buffer now has FF. So if you had to count them, 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. We copied the FF. Now, in theory, okay, in a way that is correct. Actually, I should have done. No, sorry, I did the example wrong, because of course, if you take the line now, it is 12. It's 12. So let's leave it as it was. Let's do let's do define constant byte $ff. So now we have an odd address, so 11 characters, sorry, that ends at an odd address, but we are adding FF to it. But when we take the length, okay, it's still 11. And you will see that the FF is always copied. Let's do one more thing actually. Let's do also OF, comma OF. To make sure that, to know how much we are copying, and then 0, 0. So AD Okay, so hello world. So hello world ends with the letter till we have FF. So we only should see in the buffer till the 64, right? And then to make sure I have this FF, OF, OF, 00. So now we should start seeing the 48 again. Sorry, even inserted another 0 because we were at an odd address, and now we see the 48. There you go. So now they should match. Okay, but let's see if we copy the FF. There you go. We copied the FF. That is a better example of what was really happening. Example 6. So again, we copied the address into 80. We copied not the address of the tables into 80. Now we need the third or second, because we start from 0, from the list that we have in the table. Okay, and I am indicating it with this. What we need, it's this line. So to do that, we do 4, because each defined constant is always 4 bytes. So 4 times 2, because we need the second one starting from 0, right? So the 0 will have the value of 8. Now, before you saw a value, bracket, an address register, close bracket. Now you're going to see another addressing mode where we have the address register plus a data register. Okay? And we move that value into the 1. Okay? Now, what you don't know is in front of the bracket, we still have a 0 there. Okay? You can have another value there in this addressing mode. Okay? So actually what it does is it takes the value outside the bracket plus the value of the address plus what we have in the 0, adds them all together, all three together, and what we have in that, what is the value of that address, we will copy. Okay, in this case we are moving .long into the 1. Okay, so here there's a silent 0 there. And notice, so as you see, the 0 has the value of 8. And here Docster didn't use move quick. Now we copied what was in 80 plus 8. So the address of the table ends with AA, right? We took the address that ends with AA, added the 8 to 80, and we copied the long word that was there. So if I had to do M tables, we should see that our address, so the start address of the table is AA, with the address that ends with AA, and then 8 after. Okay, 1 2 3 4 1 2 3 4, we have the long word, so starts with 0, 0, 0, 0, 1F, 1F. Sorry, 1F, FF. It's our value in the, the, the place that what we wanted. Okay? Is it clear? Any problems? So we finish this example. I have this one. This is a simple one, but we are going to use this stack. Okay? When we want to use registers to move to the stack, we use the move M, and we copy the whole address normally, the whole data register. So dot long, okay, not dot word. You can use dot word, but normally it's dot long. And you copy the registers, the 0, in this case it's the 0 to the 6. It could have been the 0 to the 7, but Docster didn't want the 7 for some reason. And also we are specifying to copy the address registers A0 to A6. Remember, A7 is the stack pointer, so we are copying to the stack pointer, and the stack pointer grows downwards, moves downwards, so minus. Okay? And we could replace SP is stack pointer. We could also write A7 there. Okay, so A7 is a register that we don't really use in our code. Let's say that you can use it, but you are at risk. So we copied all these registers, these 12 registers, okay, sorry, 14 registers, into the stack. To get them back, okay, we use the stack pointer, and this time is plus. We're going upwards in memory, and we use the same syntax, D0 to D6, A0 to A6. Okay, you don't swap or change these. So you should see the stack pointer changing from where it is. You see the value in A7 and the value in USP. Okay, they are the same. Now they changed. And we do the same thing with the next instruction. There is something. I don't know what happened there, but so we execute this one. Yeah. Funny enough, the SSP. So maybe this is. I always thought USP is the the user stack pointer. I don't know, guys. That is strange to me. Yeah. I don't know if it's a bug right now, or I'm interpreting something wrong, because A7 did not move. To be honest, it should grow downwards. So I'm just going to run it again, because So it is D114, the SSP. Let's see to what number it goes. Ah, it's the one that decremented. And now it should go to, again, to what it was. Ah, that's strange. It should be... Why A7 is not changing then? I don't know. Guys, I really do not know this. I'm getting the feeling there's a bug in Pro when it comes to this. Because A7 should be changing. Anyway, it's not that important in the sense you don't use A7. Try replacing SP with... Okay, yes, okay, let's do that. It could be a bug, stupid bug like this. So, let's see. Still. Nah. Still the same. I do not have an answer to that. Yes, I really do not have an answer to this. It should be A7 that is changing, and not the supervisor stack pointer. But yeah. Hold on. Okay. When you are tracing, when you are debugging, what stack do you use? Supervisor mode. So the debugger cannot handle that. The trace command to trace the instructions is when you have supervisor mode. So that's why it is changing SSP. That's my only thinkable way to answer to this issue. I mean, they should do something to update actually A7 because we are in user mode. But yeah, in the status register, okay, there's a flag that says, okay, trace the CPU. I mean, debug the CPU, but it's trace. Actually, it's called trace. So yeah, I think that's why the SSP is changing, not the A7. But if you had to run the program in a normal, actually, guys, let's do one thing, okay? Let's run it. Let's run it in the 68K simulator. Right? Let me do that. It should be doable, and see what it changes. So you can now see the screen, right? Okay, so let's run it. Let's see what's going to happen to this stack pointer. Execute, and this one always goes to the screen, but I have to bring it here, and it has this one also to bring here. So A7 is at this address, okay, and we have the user stack pointer, I assume that, and this is the supervisor stack pointer. Anyway, let's see which one is going to move. These two are the same, so I'm wondering why. Well, we are in debug mode, so it is supervisor mode that we are. So let's see if it does the same thing. So A7 changed. And it's reflected in the supervisor stack pointer. It's more accurate, I think, here, because although user stack is still is this, because we are in trace mode, it's using the supervisor mode, but supervisor mode is reflected in A7. So I think it's more clear here what it really does. And then we went back. Yeah, I think this is better representation of how it is done. But this user stack pointer is actually here. It's because we were in supervisor mode, so we had to use the supervisor mode stack pointer. It cannot switch to the user stack pointer. Probably there's a note of this in the manual. Probably. Just something interesting, let's say that. Good to know, no? Anyway, I hope you like more than what I hope to be faster also, because I had more to do. But yeah, hopefully next time it will be faster, but at the same time I hope you liked this session. I really would like to do most of the instruction set and show you how to use the instruction set, but then after this I want to return to writing games for the Amiga. So once this session is finished, the series will continue with Let's Make an Amiga Game, and it will be volume 3 or volume 4, whichever comes next. I think it's 4. Anyway guys, have a lovely evening, have a good week, and see you next weekend, unless something changes in my life. See you guys, bye bye.